Okay, so I decided to make another video about some stuff from homework too, specifically the trig stuff, because I got some questions about that. Um, so at the top, I just put, I mean, this isn't like a complete everything you would ever need to know about trig, but this is some pretty useful stuff. Um, so let me talk about this one, and let me emphasize this is supposed to be the unit circle, so this is 1, 1, negative 1, negative 1. But, so if you have an angle of theta, and we typically measure this from the positive x-axis. So this is the positive x-axis. This would be the negative x-axis, so this is the positive one. And we measure the angle starting from the positive x-axis. So it goes from here to wherever it is. So you measure whatever angle you like. And if you follow that out to where it hits the circle, the coordinates of this point are cosine theta and sine theta, where theta is whatever this angle is. This picture can help you figure out some sines and cosines. This is another couple of pictures that can help you figure these things out. These are two very common triangles. This is the 45-45-90 and the 30-60-90. And you should keep in mind that these are ratios, like the side lengths. For example, I could double all of the side lengths. Like I could make a bigger 45-45-90 where this would be 2, this would be 2, and this would be 2 root 2. So keep in mind that these can be like, these are just ratios, so you can double it or triple it or whatever, and it's still a 45-45-90. But this is the one I remember. I remember 1 here, and root 2 here. Similarly for the 30-60-90. By the way, of course, there's degrees and then there's radians. These triangles up here I labeled in degrees. If you ever want to convert to radians, you just take the however many degrees it is and you multiply by pi over 180. Of course, you can go the other way. So if you have something in radians and you want to convert it to degrees, you multiply by the reciprocal. You would multiply by 180 over pi. Here, of course, I wrote SOHCAHTOA. This is I don't know if people remember it this way, but this is one way to remember that, for example, the sine of an angle is the opposite over hypotenuse. So like the sine of 30 would be 1/2 because this is the opposite from 30 and this is the hypotenuse. Similarly, cosine is adjacent over hypotenuse and tangent is opposite over adjacent. This is a picture of quadrants and like where the trig functions are positive. So they're all positive in the first quadrant. Sine is positive in this quadrant, but cosine and tangent would be negative. Tangent is positive in this quadrant, but sine and cosine would be negative. Cosine is positive in this quadrant, but sine and tangent would be negative. And yeah, and one more thing about inverse trig functions like arc sine and arc cosine. And by the way, you sometimes see these written this way, and this is how I say it out loud. I say arc sine. And similarly, you would often see this written arc cosine, and that's how I say it out loud. But when I write it, I typically write it this way with the -1. This -1 looks like a power. I mean, typically this is where we would write a power, but this is not a power. This is an inverse function. So what you want to remember about is that arc sine is always between -pi/2 and pi/2, and arc cosine is always between 0 and pi. So let's use this information to do a few things. So let's find the arc cosine of 0. So I want to find an angle whose sine or an angle whose cosine is 0. And since this is an arc cosine, my answer should be between 0 and pi. So what I'm going to do is I'm going to look at this picture. I want an angle whose cosine is 0. Cosine is the x-coordinate, so I would like to have an x-coordinate of 0. And my answer should be between 0, so this is an angle of 0, and this is an angle of pi. So I think I see the point I want to look at. Here's a point on the circle with an x-coordinate of 0, right? Cosine's the x-coordinate, so I want an x-coordinate of 0. So I see this point. This point would correspond to the angle of, well, 90 degrees because it's pointing straight up. In this class, unless you're told otherwise, let's use radians. I know that people like to think in degrees, and the truth is that I do too, but it's also true that in calculus we use radians. Everything is a lot more convenient. I'll talk about this more later, but and I know that radians can be annoying, but there's a real reason we use them in calculus. So convert this to radians. It's not that hard. You multiply by pi over 180, and so that's pi over 2. Okay? Arc sine of 1/2. Now I have to think. I could try the same method because this is like I want to find an angle whose, oops, I'm going a little bit off the screen here. I want to find an angle whose sine is 1/2. I could look at this picture, but I'm going to have a hard time. The sine is the y-coordinate, so I want a y-coordinate of 1/2. But it's hard for me to see, like I'm sort of tracing the line with a y-coordinate of 1/2, like 1/2 would be right here. So maybe I could look at this point or this point on the circle, but I can't really tell, like looking at this picture, I can't tell like where this point is exactly. It's hard. What I can do instead is look at these pictures and just sort of hunt around to see if any of these angles would give me a sine of 1/2. Of course, sine is opposite over hypotenuse. I see some, so if I'm going to get a half out of this, I have to do, well, 1 divided by 2. So I see some 1s here, but this would be root 2. So if I did like the sine of, for example, if I did the sine of 45 degrees, that would be 1 over root 2, which is not the same as 1/2. What I should do is sine of 30 degrees, because that would be 1 over 2. And again, we should convert this to radians. If you multiply by pi over 180, you'll get pi over 6 here. Okay, so let's keep going. Let's do the tangent of 3 pi over 4. So this one is actually not an inverse trig function. This isn't arc tangent. There's no -1 here. I'm just finding the tangent of an angle. It helps to find the angle, which is like this. And by the way, maybe just to help you think about it, even though, you know, ultimately we do everything in radians, but just to help you think about it, it might help to convert this to degrees. If I multiply this by 180 over pi to convert it to degrees, I'm going to get 135 degrees. And that can help you draw the picture. Like that, for example, that tells you that I'm going past 90 degrees, but I'm not going. So it's somewhere in between 90 degrees and 180 degrees, so I draw it here. So here's how we're going to do this. Since this is not in the first quadrant, so I'm going to have to use this picture to figure out whether it's positive or negative. Actually, I can tell right now. I'm in this quadrant. This is the quadrant where sine is positive and everything else is negative, and I'm doing tangent, so it's going to be negative. So I'll just write. I know that now. So it's a negative number, but of course I need more information than that. I'm kind of just drawing the same picture, but I want it to be a bit less going on here. I'm drawing the reference angle, meaning normally we measure the angle from the positive x-axis, but if it's in a different quadrant, then you might measure it off of the negative x-axis and call this your reference angle. And for right now, I'm just going to do stuff in degrees. In the end, I'm going to have to make sure not to use degrees, but as I do my work, it doesn't really matter. I find the tangent of the reference angle, and I do that from here. Tangent is opposite over adjacent. That's what this tells me. And I can look at this 45 or this 45. It doesn't really matter. Opposite is 1, adjacent is 1. So tangent of 45 is just 1 over 1, which is 1. The tangent of what I really wanted with 3 pi over 4 is going to be the same as that, except I just have to take into account that I figured out that it was negative. So instead of 1, it's negative 1. Great. Now let me do, so in the online homework there's a couple like this, where you find a trig function with an inverse trig function inside of it. So for this, I would suggest draw a picture. I'm going to draw a triangle that has an angle that I'm going to call theta. And I'm going to make sure that theta is the arc sine of x. Oops. In other words, I'm going to make sure that sine of theta is x. And let me do something a little bit funny looking. X over 1. I'm doing that because sine is opposite over hypotenuse. So if I want the sine of theta to be x over 1, then I'm going to make the opposite x and the hypotenuse 1. Right? Opposite over hypotenuse. Okay, now what you do is you use the Pythagorean theorem to figure out the third side. So I could do this quickly, but maybe I'll show my work. I'll call it y, and then I'll solve for y. I'm using the Pythagorean theorem. I solve for y, so y squared is 1 minus x squared. So y is the square root of 1 minus x squared. And I don't put plus or minus because y is a positive number. Y is the length of this side. And by the way, I know some people are going to try to do this. This is not the same as 1 minus x. Of course, this is tempting to do because the square root of 1 is 1, and the square root of x squared would just be x. But you can't, if you have addition or subtraction inside the square root, you can't just individually do the square root of each one. It's just not the same thing. So don't write this. This is the answer. Or, sorry, this isn't our final answer yet, but this is the answer for y. Our final answer is going to be, of course, we wanted the cosine of arc sine x, and theta is arc sine of x. So what I want is cosine of theta, and so now I just look at theta, I think about what cosine is. Cosine is from SOHCAHTOA, TOA. This is adjacent over hypotenuse. The adjacent side would be this, the hypotenuse would be this. And then I can simplify. And then that's my answer. Okay, good. Let me now just do a couple of domain questions. And the good information to have here is in order to do cosine of theta, or sorry, arc cosine of theta or arc sine of theta, the thing we're doing the arc cosine or the arc sine of just needs to be between -1 and 1. That's how you talk about the domains of these things. And this is directly just because the cosine and sine of anything is between -1 and 1. So if I'm going to do the arc cosine or the arc sine of anything, whatever that is has to be between -1 and 1. So knowing that, that's going to make part A easy. Whatever I'm doing the arc cosine of just needs to be between -1 and 1. And then I can solve for x. I'll subtract 2, and the way this works is I subtract 2 from everything, so -3 less than or equal to 3x less than or equal to -1. And then I'm going to divide everything by 3, and I'm dividing by a positive number, so I don't have to reverse the signs, or the directions of these inequalities. If I divide by a negative number, I would have to switch the directions, but I'm just dividing by 3, so I don't have to do that. So -1 less than or equal to x less than or equal to -1/3. So this is the domain. If I want to put this in interval notation, it's -1, -1/3. With square brackets, because the domain does include -1, it also includes -1/3. For me, I would accept either of these answers. The online homework, I believe, prefers interval notation, so probably this way if you're doing the online homework. But if it's a written quiz or test, I would accept either one of these. Okay, so just one more. This one is just a slightly harder because this involves an arc sine and a natural log. So let me work my way from the inside out. If I'm going to plug a number into this function, the first thing I would need to do is to find the natural log of x. In order to do that, I can only do logarithms of positive numbers. It's not greater than or equal to 0, because I can't do the logarithm of 0. It just has to be strictly greater than 0. The next thing I would need is I would need to be able to do the arc sine of whatever I got. So whatever this is, whatever the natural log of x is, it had better be something that I can do the arc sine of. In other words, whoops, it had better be between -1 and 1. So let's solve this. The nice thing about this, if you remember, the way you get x out of a natural log is I'm going to do e to this power. And I can just do e to everything, like e to this power, e to this power, e to this power. And the inequalities go the same direction. So I'm going to get e to the -1, which is 1 over e, right? -1 power means reciprocal. This, they just go away, and I just get x. And this is e to the 1, which is just e. Okay, so I'm basically done. Let me just assemble my answer. So I found two things. I needed x to be greater than 0, and I also needed x to be between this and this. And now if I think about it, that's a little redundant, because actually all of the numbers in between here and here, because keep in mind that e is a positive number, e is like 2.7. So 1 over e is also a positive number. So actually all of the numbers between 1 over e and e, they are greater than 0 anyway. So this is a little bit redundant, or it's entirely redundant, I would say. This is the only important one. All the numbers in this interval satisfy this already. So we can just say that this is our answer. Of course, if I want to put it in interval notation again, it's like this. Okay, so yeah, I hope this video helps you do some of the trig and inverse trig stuff out of homework too. But feel free to keep shooting me questions as you go.